Well, hello there. This is section 1-4, day 1. Today I wore my lucky shirt. This is a mountain to climb, and for me to communicate this to you without you being in person, it just feels like an impossible task because it's so much Q&A in the process. So I'm just going to hope that you guys rewind and watch it again, or send me a message on Schoology Messenger, like, I didn't quite understand that, but here we go. We're going to tackle this, okay? We're getting into graphing. Collective sigh of depression, get it out of your system. Get it out of your system. It's not just graphing, it's graphing trig functions, mainly sine and cosine. Now, back in the days of semesters, we would actually go sine, cosine, tangent, and then we'd actually look at secant, cosecant, cotangent. But you guys are getting the bare bones. Trimesters kind of got to the meat and potatoes. You're going to notice I use that phrase a lot, but let's get going. Again, this could be 2 parts because this is a huge undertaking. Okay, let's go. So 1-4, day 1, pre-lesson. Now, what is this? The title of it? Well, if you look in your handy dandy packet on page 33, you're going to see right here this crazy looking formula: y f of x equals a times sine of da 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 da. Well, we got to try to make sense of the da 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 da. Okay, so notice on my board I've written y equals, in your paper it actually says f of x. Well, those are equal: g of x, h of x, f of x. If you go back to algebra 2, those equal y. I'm not going to talk about that right now. That's just a fact, Jack. So that's our goal right here. Understanding what in the world this is. What does this do to the graph? What does this do to the graph? What does this do to the graph? And what does that do to the graph? So that's our goal. What is A? What is B? What is C? What is D? But what I'm going to do is take you from the world of the familiar, hopefully, to the world of the unfamiliar, and then that unfamiliar world will just kind of click a little bit better. So without further ado, let's take a look at this. Y equals 2/3 x plus 1. This is a linear equation. Notice this has nothing to do with sine, cosine, tangent. This is just to get the basics going. Now, what is this? Well, if you notice it from pre-algebra, algebra 1, algebra 2, who knows, geometry, this is the graph of a line. Again, I'm not going to reteach that whole thing, but if you look at this, you recognize it as y equals mx plus b. You know, you haven't done it in a while, so maybe it didn't pop out at you, but this is part of pre-calc. This is the value of the pre-lesson. It's like, whoa, you guys should know this stuff. I bet you were rusty on that. Anyways, we graph this first, so that's our y-intercept. So we go up 1. That's what that is. That's our y-intercept. And then remember, this is our slope. What slope? Slope is rise over run. But remember, rise doesn't necessarily mean up. If that top thing is negative, rise means down. So I know that's a little counterintuitive, but you just got to get used to that. But this is all positive, so this is up 2, and this is to the right 3. Remember, it's rise over run. If the run is negative, you go left. If the run is positive, you go right. So from this point, not the origin, but from the point, you go up 2, right 3. There's your second point, and voila, you got your line. Is today's lesson about how to graph lines? No. Well, why are you talking about this? You'll see. So example 2, y equals x squared. What is this? Well, if you ever look at this and you're like, oh, I remember seeing stuff like this, but I don't remember what it looks like. You can always use this method, just plug and chug. So -3 for x, square it. -2 for x, square it. -1 for x, square it. 0, 1, 4, 9. And these are all my points. Now, I'm not going to be real good at plotting these and worrying about the accuracy of it. Just trust me, if I plotted all those points, it would look something like this. This is called a quadratic equation, just a parabola, okay? And if you look at this point, -3, 9, like 1, 2, 3, and we go way up to 9. But I'm just giving you a general idea today. Now, a couple hidden pieces. There's actually an invisible 1 right in front of that x squared. I don't know if you can see that. Let me check my Yeah, you can see it pretty good. So that's a 1, and that is my letter A. Notice, A is my coefficient of the whole darn thing. It can be a whole number, it can be a fraction, it can be a decimal. And what does that, what happens to the graph if it's a whole, big old whole number like a 9 or a fraction like a 1/2? That's what our goal is. But in this case, there's an invisible 1. And then there's actually, over here, is a 0. That is our letter D. Sorry, I made it capitalized, but D. So it's whatever's on the end. That right there, just to kind of get the ball rolling, if that's a positive number, like a 5, it goes up 5. If it's a negative number, like -5, it goes down 5. So because there is nothing, there is no change. By the way, let's go back to this 1. What does this 1 mean? This 1 means it's normal. You got to know what normal is. So we just defined this as a normal parabola. Now remember, they can go like this, they can be wider, or they could be narrower. And those are considered to be abnormal or just not normal, okay? Get the idea? So let's go on to this one. We're going to really mess around with this one, okay? You got to stay with me on this, because now the heart of it kind of starts showing up. Notice what I've done. I've inserted parentheses. That is matching this. Now notice this is squared. This is not squared. The rules are the same. And this is true for all graphing. That's the beauty of it. So it's not just about sine and cosine, your trig functions, and how to graph them. These are rules for all graphing. And by the way, in pre-calc, we're going to do a lot more graphing, and we're going to refer to these rules. We're going to say, remember when. So these are big rules to have. Anyways, so what do we have right here? Well, there's an invisible 1. You have to know that. So if I asked you, hey, what's the letter A? You'd say, it's 1. Then I ask you, what's the letter B? You'd say, oh, okay, because there's parentheses, there is a B, and that is a 1. Okay? Go back to over here. There was no B, because there was no parentheses. Keep that in mind. What is C? C is -1. There's my little A, here's my B, here's my C, and there's my D. They're starting to show up. But what do they do? We're going to talk about that. So let's just go ahead and graph this. Let's plug this in. I'm going to do this quick. -3 minus 1 is -4 squared is 16. -2 minus 1 is -3 squared is 9. -1 minus 1 is -2 squared is 4. 0 minus 1 is -1 squared is 1. There's my 1. 1 minus 1 is 0. 0 squared is 0. This whole side just equals 0. 2 minus 1 is 1. 1 squared is 1. That's 1. 3 minus 1 is 2. 2 squared is 4. So I get 4. Now I'm going to start with this point. I've done a million of these, so I just know where to start. So that's right there. 1, 0. Now I'm going to move up. 0, 1 would be right here. 2, 1 would be right here. And can you see what's already happening? It's going to be like this. And if you don't believe it, you can take a look at these other points and just plot them, but I'm not going to take the time to do that. All I want you to know is this. Notice this says x minus 1. Remember, this is my x-axis, this is my y-axis. Notice the x-axis is basically going to the right, going to the left. My y-axis is either going up or it's going down. What happened to this equation compared to this one? This has a -1. If I was to give you a multiple choice and I said, hey, A, that's going to move it left 1, or B, that's going to move it right 1, and you didn't already know the answer, I bet you, and it's true for me, I would have said, hey, I think that moves it left 1 because of that negative. Now, what actually happens? Well, notice this vertex right here moves where? It moved to the right 1. So that's what this -1 did. So you just learned a huge rule. If this is a minus right here, that's going to move it right. But if that's a plus, it's going to move the whole graph left. So if that was x plus 1, it would have taken this normal parabola and moved it left 1. And it would have been over here somewhere, okay? Now let's look at the rest of this. See this 1 right here? That means this parabola should have been absolutely exactly as wide as this one. And it is. I mean, I'm hand drawing it, but it is. The question is, what would happen if I make that 1/2? Well, essentially, I would take what I got here and I would multiply it by a half. So this wouldn't be 16, it'd be 8. This wouldn't be 9, it'd be 4.5. This wouldn't be 4, it'd be 2. This wouldn't be a 1, it'd be 0.5. This is still 0. This would be 0.5. This would be 2. If you look at it, it's just my y values do not go up as fast. So that would make, let me get out a different marker here. Let me circle this. I hope you guys can see the green. My marker's already dying. It would make it wider. Oh, that's bad. Okay. Can you guys see that? Barely. But you get the idea. And I'm going to go with a blue marker and see if this, there we go. That's going to show up a little bit better. So, look at guys. If this is a positive, but it's also a fraction, it's going to make it wide. I mean, that's the word we're going to use for now in the world of parabolas. Now, what would happen if I actually slid a little negative in there? Well, that would take all these y values and make them negative, 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 negatives. What does it do? Well, I say it flips it. So it would take this green one and it would flip it. So I'm trying to duplicate it. Now, pre-calculus will say it reflects over the x-axis. So you got to get used to this fancy talk. So that's another challenge. How to talk the talk. Okay? Also, the language used, I said it makes it wide, and that would be called two things. It would be called a vertical, oh boy, sorry you guys. It's called a vertical shrink by 1/2. Where'd I get the half from? Right here. Or it would be called a horizontal stretch. In other words, horizontally, left to right, it's stretching. Vertically, it's just not going up as fast. So pre-calc expects you to be able to say both of those things. So now I'm introducing you not just to graphing rules, but also the vocabulary. And they're equally important. That's going to be on your quizzes and tests. How to talk the talk. Multiple choice questions, and they're going to use this language, so you got to get used to that. How much time do I have left? All right, like 2 minutes. So I'm just going to kind of finish with this. Letter A, if it's negative, it flips or reflects over the x-axis. If it's a fraction, then it does this, vertical shrink or horizontal stretch. And so I'm just going to cheat and say that. But if it's a whole number like a 2 or a 3, now I'm going to go ahead and just show you this. So if I was to erase this and go like a 2, that would take all my original values and double them all. What that means essentially is that original guy right here would go up extremely fast. So 2 things happen. Number 1, it's a vertical stretch by a factor of 2. Why 2? Because I put a 2 there. Or it's a horizontal shrink by 2. In other words, it's getting shrunk by a factor of 2. Now this is very confusing. We'll talk about this in class. You could also say by 1/2. And I got to end in 30 seconds. Why are both of these acceptable? Well, if you shrink it by 2, that's like dividing by 2. But if you shrink it by 1/2, that's like multiplying by 1/2. That's the same thing. So the language gets a little bit wonky in there. And you can say both things, but it takes a little bit to think about it. I know this is new. You gotta let it marinate. We'll talk more.